This is topic 1.8, valence electrons and ionic compounds. This should be a good review of what we've already done. We've talked about a lot of the things, so it's going to be a fairly short discussion here. So one of the main learning objectives for this topic is figuring out the number of valence electrons that are in different atoms. Well, that simply has to do with the group number and the location on the periodic table. And so everything in group 1 here is going to have one valence electron, right? So group 1 is one valence electron. Group 2, two valence electrons. Jumping over to the P block over here, group 13 has 3. Group 14, so here's group 13, group 14, group 15, 16, 17, and 18. And then in black is the number of valence electrons in each in that group. So the S block is pretty predictable. The D block, we don't really go there in terms of talking about valence electrons because things get a little bit, sideways in the D block. And the F block, forget about it. So then what charges do the ions tend to have? And you're going to need to know these charges, but again, it's pretty simple. Atoms are going to gain or lose electrons in order to, and when they do, they'll have that noble gas electron configuration. So if we look first at, say, something like fluorine. Fluorine's really close to neon here, the noble gas, and fluorine has 9 electrons as an atom. Neon has 10 electrons, and so it has a full S and P subshell. So in order for fluorine to have that full S and P subshell, it would gain 1 electron. Right? The other way to look at that and express that is it would take, since fluorine has 7 valence electrons, it would take a whole lot of energy to remove all 7 of those valence electrons. And so it is easier or takes less energy to gain 1. Similar argument with oxygen. It will have a charge of -2 because it's kind of 2 steps away from a noble gas, and so, or 2 steps away from having a full S and P subshell. It doesn't know that. All it knows is that it's easier to gain 2 and really hard to lose 6, right? It takes lots and lots of energy. Nitrogen and phosphorus. So the non-metals, you'll see the metals down here. If you remember the staircase, right? The staircase is kind of blocking off, or the dividing line between metals and non-metals. So many of these only apply to a limited number of atoms in each group. Group 13 here is +3, so that's aluminum and gallium. The other ones down here, the other metals here, are not predictable. They could have several different charges. And we've got kind of this nice little triangle section here. So going from left to right, we're 1+, 2+, and 3+. The group 1 and group 2 metals, very predictable in terms of their charge. Group 1 will have a +1 charge, and group 2 will have a +2 charge. So quick practice problem here, and then you can get off to work on the idwoodids. So we're looking at number 117, tennessine, which is right here. Recently named, assuming that the periodic trends are followed. Write the noble gas electron configuration and predict the formula when it forms an ionic compound. So if we go backwards from tennessine, we see that radon here is the noble gas. So that's Rn. And so that's 1, 2, 3, 4, 5 in the 6th period. So we know that radon then ended in 6p6. Well, if we continue looking here, then comes next 7s. Now follow the atomic numbers closely. You see that 89 to 103 are down here in the F block. Right, and so remember this is 4F and 5F, so after 7s2 comes 5F, and since tennessine is not in the F block, we know that that's going to be completely full. And so then as we're kind of progressing toward tennessine, we have to go through the D block, And so remember, the D block is the period number -1. So if this is period 8, then this has to be 7D. Excuse me, not period 8. There is no period 8. Period 7, this has to be 6D, right? 3D, 4D, 5D, 6D. 6D10, we're going all the way through the D block here. And so then we enter the P block. So that will be 7P. And tennessine is in the 5th column of the P block. So there's the noble gas electron configuration for tennessine. Now, when it becomes an ion, again, to have that full SNP subshell, we can see that 7P5, that's pretty darn close to 7P6. So it's going to gain 1 electron, again, if it follows. And so it will have a -1 charge as an ion. So good luck with the idwidids. Let me know if you have any questions.